Welcome to our next example. Today, we're going to do an actor that is going to be serializable, so it will be able to save itself. So, how can we do this? Let's start again. Let's create a class that is an counter actor. Again, it's going to extend from our actor, and it's going to have a constructor that is going to have also a name. So let's give that name to our parent. So super.name, and let's add one. And let's do this dot counter and an increment there. And let's say that we have a counter equal to 1. Oh, like before, let's now create an actor system. So let's call our actor system, and we're going to create an actor system. Let's start with the default one. And now we can create our actor. It's going to be the actor system. And we create an actor of type counter actor with no parameters. Oh, yeah. Uh, Actor. Let's call it like that because we're now passing a name. Or let's call it that. And with this in mind, now we can actually do a actor dot add one. And let's do this a couple of times more. And with this in mind, now we can actually do a print line here. And let's print this dot counter. And if we run the application, we will see that it does 2, 3, 4, 5. And that's what we actually want. The problem at this point is that whenever we actually restart our application, it will always count from the same point. What happens if we want to persist that? Do we need to implement the connection to the database, save it, etc.? With Tarant, that's not the reality. Tarant, it's an extensible framework, and we provide these modules for you. We think that this is not where you need to actually focus your effort. You should focus your effort on the domain logic that you're actually writing. So, how can we do this? We'll need to install a package called Tarant DB Persist. So, let's go to our console and install our dependency. When this gets installed, then we can create our persister. So, with this in mind, now that we have it, let's do persister, and we're going to await the persist resolver materializer that is going to be created. Uh, and this requires a configuration and a type. So let's go for it. So for this, we're going to do a constant of db configuration. And we're going to pass this db configuration here. And we need the type of things it needs to resolve. In our case, our counter actor. Now, you need to create your actor system. So with that in mind, you're going to do an actor system. It's not the default anymore. It's an actor system 4. And here you do actor system configuration builder. You define a new one. Where basically you will have a set of materializers that are the how they actually generate the new instances, and it's going to use this instance to actually it's actually how you update things. So you will use actually this persistor there, and you're going to do with resolver. I'm missing that. With resolver. Resolver is the way that it actually is able to find new existing instances. So with this, it's going to be able to first recover them and also save them. We'll take care of that for you. And then it's done. We have built our new instance with the materializer. With this in mind, this is all that you need to actually do to save an actor in its state. In reality, there's only one step left to make it to be able to run this example, and it's providing the DB configuration. Tarant DB persists, the module, uses below a waterline that is an ORM. Another package, another uh, library could use a different one. In our case, we added waterline. So, how does this configuration work? Let's get into it. We will add the disk adapter from NPM. And when this is installed, we will have the capability to actually add things to our database. So, this in mind, let's now add the configuration. So the db config requires an adapter. That in this case is our disk adapter. And with this, we need to initialize that. That is our const disk adapter. It's required from sales disk. And we just need to define the data store. And the default one is the one that we've just defined. This, our system is configured. This is all you need to actually do to add your database. Now, how is this actually saved into the database? We don't think that the logic should be added to the object itself, to our class. So we've added some tools around Tarant that will allow you to decorate this. So now you just need to add the utils. You do like before, an npm install. And now we can decorate our class. So this is a class that is a serialization. And this extends our decorator, and it's going to decorate the instance of the counter actor. And you can do a constructor with the actor. is not needed because we're not in TypeScript. So if we do a super of this actor, and then the decorator itself for the serialization, it asks you to do the to JSON and an update from. So the JSON module will just return how is it going to be serialized. So in our case, we know that this has an ID. That is the one that we pass as the parameter. So we're going to save this. So this actor.id. We're going to also provide a type that is going to be equal to the count name of our class. This is going to be searching here. We could give it whatever name we give on the configuration. And we're going to add any other value that in our case is the counter value. So it's going to be this actor.counter. And with this, we'll be saving in our database. Now, when we actually receive something, we can serialize it and update our actor itself. So for this, let's say that we're going to receive the information, but we only want to know the counter. And we're going to do this actor.counter equals the counter. Okay, so now we just need to decorate our actor with this decoration. So let's call it our counter actor. It's going to be decorate of the one that we already have. Let's call it base just to make sure they don't have the same name. And we decorate the counter base with any decorator that we actually are going to generate. And now we have an actor that is a counter, and it's decorated with the serialization. You can split this however you want on your application. We have an await here, so the problem is if we do npm start, it's going to load because we cannot actually do an await at this level. So let's wrap this into a run method. That is an asynchronous, and with that in mind, we just need to have this, and we are going to move everything into this method itself. And we're going to call it. Last but not least, at this point, we're always restarting or creating an actor from zero. So if we do npm start, now we are getting the value. And we're going to continue doing the value. But in reality, we're actually saving the data on our database. Why is this happening? Because we're doing an actor of. We actually need to try to resolve it first. So in our actor system, we can do actor for, use the name that we gave it. So in this case, app. And if there's any issue, then we just are going to create a brand new actor. So with this, we're going to do the catch. We are going to do the actor system, actor off, and we're going to resolve this as a promise. With this, we can await. And now we're going to be generating an app. Whoops. We're going to try to resolve it first. And if not, we're going to create a new one. If we do npm start, now it's starting to count from wherever it has saved before. This is a realization in Tarant. As simple as defining your domain logic, keeping it there, and add the decorator that you actually need. This decorator can be used also by other plugins. We will see later on in another chapter. Thanks for watching. Any feedback is welcome.